This stealth aircraft is designed to be invisible to radar. How? Its angular shape scatters radar waves away from the source, and radar absorbent material on its skin absorbs the energy. This makes it officially invisible to radar.
In 1943, British bombers were decimated by German Wurzburg radar. But if you are made of metal and in the sky, you are a beacon.
For decades, the impossible barrier in aviation wasn't just breaking the sound barrier, it was also overcoming the heat barrier. Pushing the limits of speed meant conquering both, a challenge that defined a generation. For decades, the impossible barrier in aviation wasn't just breaking the sound barrier, it was breaking the law of reflection. The barrier that made aircraft invisible to radar. To the laws of physics, a traditional Boeing 747 doesn't just look like a plane on radar, it looks like a glowing sun. To understand stealth, we have to stop thinking about what a plane looks like to the human eye and start thinking about its radar cross-section, RCS.
Let's compare radar cross-sections. A B-52 bomber is 100 square meters, an F-15 fighter is 25 square meters, a bird is 0.01 square meters.
To put that in perspective, the F-22, its top speed is nearly 1,500 miles per hour. That's more than twice as fast as this airliner. But why? Why must a stealth plane look so sharp? Angles and flat surfaces are designed to deflect radar waves. This stealthy design is more important than perfect aerodynamics. This is the F-117. It looks like a diamond-cut nightmare, because its sharp angles scatter radar waves, making it nearly invisible. In the 1970s, our computers weren't powerful enough to calculate how radar waves would bounce off curved surfaces. We could only use diagrams to approximate the scattering patterns. Do we make it fly well, or do we make it invisible?
Why not both?
Prototype is ready. Let's see. Activating stealth mode. Perfect, it's gone. We could only calculate flat facets. Engineers had to choose. They chose invisibility, and the result was a plane so aerodynamically unstable, it required 4 flight control computers just to keep it from falling out of the sky. The physics of light is described by James Clerk Maxwell's equations. Specular reflection occurs when light hits a smooth surface, like a mirror. This principle enables technologies like lasers and telescopes. The first principle of stealth is specular reflection. By positioning your body at the right angle to a reflective surface, you can control and minimize your visible reflection. If a radar pulse hits a surface at a 90-degree angle, 100% of that energy returns to the enemy.
What is planform alignment? Anyone know? It's about aligning an AI's goals with human values, so it helps us without going off track. It's key for safe AI. What do you think?
Every edge is aligned. If you look at the B-21 or F-35, the wings, intake edges, and even the landing gear doors share the same parallel angles. This is called planform alignment. But geometry isn't enough. Low-frequency search radars have wavelengths so long they wrap around small objects, a phenomenon called Rayleigh scattering. To beat this, we have to move from geometry to material science.
J. Mariano, MD, physician and surgeon, a pioneering figure in 19th century medicine, he dedicated his life to advancing patient care and medical research. Known for his...
Today we are going to tell you of a personality. Stay connected with us, subscribe to the channel, and like the video. To stop the waves that geometry can't deflect, we use RAM, radar absorbent material. This isn't paint, it's an engineering marvel. From a physics standpoint, we are literally eating the radar's energy and converting it into thermal energy, heat. But here is the skeptical reality. RAM is incredibly heavy and fragile. On the B-2 Spirit, the skin was so sensitive it would degrade in the rain. We traded maintenance and durability for a ghost-like presence. The weight of RAM coating on a stealth fighter jet is around 2,000 kilograms. This is a quarter of its 8,000 kilogram payload capacity. Designers must balance stealth with payload for optimal performance. Engineering is the art of compromise. To stay invisible, you must hide the engines. But engines need massive amounts of air. Engineers designed S-ducts to hide the reflective spinning fan blades, but this creates boundary layer separation. The B-21 Raider costs roughly $700 million per unit because every single inch is a battle between physics and survival. Engineering isn't about breaking the laws of physics. It's about finding the one narrow path where those laws allow us to do the impossible. But physics never stands still. With the rise of quantum radar, will stealth technology become a $2 trillion relic of the past? Or can engineers find a way to hide from photons themselves? Tell us your thoughts in the comments. Stealth is not a cloaking device. It is a delay tactic. It buys a pilot 5 minutes of confusion instead of 5 seconds eye warning. As quantum radar and infrared tracking improve, the invisible plane may one day become visible again.